Most financial models ignore a critical reality. It's why many forecasts fail when we need them the most. Hello, and welcome to the 79th edition of Crossing Thin Ice, a podcast series about risk management for insurers. I'm Dave Ingram, and today, as always, I'm joined by Max Rudolph. Today's topic is tipping points and feedback loops. This is about the missing element of many forecast models, those decidedly nonlinear tipping points and feedback loops that actually drive real-world crises and opportunities. Before we start, I do want to mention that nothing in today's podcast should be interpreted as investment advice, but it is sure to be educational and thought-provoking. Let's get started.
Most of the models during my career focused on linear relationships. A rising interest rate causes surrenders to increase, or rising temperatures lead to more extreme weather events. Most often we want to use A plus BX to represent linear growth, and we might even adjust the dependent variable by an exponential factor x to the b. But life is more complicated than that. Risks interact with each other, and the outcomes don't always follow a straight line or generate a normal distribution. While linear approximations often work well, especially in stable periods, external variables are known for randomness and fat tails. This is hard to model. Results may differ from our personal experience. Our natural tendency is to build a model based on recent data, but those are not always the most likely assumptions going forward. Recent experience works best when in a stable environment. Today is anything but that. So modelers should take extra time to think about what could differ from recent trends. Feedback loops can amplify or reverse changes in trend. You can think of reversion to the mean as a negative feedback loop. Those are built into many of our financial models already, noting that high and low interest rates or equity returns often even out over time and stabilize results. I was introduced to the term tipping point during my work on global warming. It was first adapted from physics in the late 1950s to describe white flight from neighborhoods as they became integrated. It can be thought of as when a trend changes slowly and then suddenly before settling into a new equilibrium. In a climate context, greenhouse gases may build up slowly in the atmosphere and oceans until something changes to force a new equilibrium as more energy is absorbed rather than reflected. Temperatures increase by more than the old models would have expected. Could be discontinuous or exponential growth replacing linear growth. Can resemble a row of dominoes that topple over once started. Compound interest may be the eighth wonder of the world, but thinking of it as a snowball rolling downhill comes from Warren Buffett. This is a positive feedback loop where the snowball gains mass and speed as it rolls. Some hypothesize that Venus once had a similar atmosphere to that of Earth. A runaway greenhouse effect has allowed carbon dioxide to dominate its atmosphere, warming the planet and evaporating oceans as the temperature rises to nearly 900 degrees Celsius. On Earth, there are several ongoing feedback loops that could create a global warming tipping point. Climate scientists have identified a concern in their models and historical data that a 3 degrees Celsius increase from pre-industrial temperatures could result in a tipping point that ensures at least a 6-degree increase. The temperature increase is driven by several variables. An albedo effect occurs when permanent ice melts, so sunlight that was reflected off ice now is absorbed by the darker land or water that is now exposed. Less radiation is reflected back into space. Temperatures rise, causing more ice to melt in a recurring loop. A similar phenomenon occurs with permafrost. A warming atmosphere melts frozen tundra, allowing the underlying organic material to decay and releasing methane, a greenhouse gas stronger than carbon dioxide. As glaciers and ice sheets on Greenland and Antarctica melt, permafrost is exposed and sea levels rise. Many parts of the world rely on mountain glaciers for fresh water. The previous snowpack is now rain, released immediately to the major rivers of the world, resulting in seasons of flood and drought. Melting ice sheets also weakens ocean currents, leaving Europe colder and slowing the Earth's rotation. Water is also a greenhouse gas, creating a feedback loop as temperatures rise that spirals as more water transitions from liquid to gas. The Amazon dieback following deforestation is an example of a rainforest losing its status as an ecosystem as it is cleared for crops and cattle. The rainforest ecosystem acts as a river in the sky, redistributing fresh water to nearby regions and impacting weather patterns throughout the Americas. Historically, according to academics Carmen Reinhart and Ken Rogoff in their book from 2009, This Time It's Different, once a country's debt to GDP exceeds 90%, it becomes inevitable that there will be a currency devaluation, hyperinflation, or default. It can be delayed, especially if the debt is owned domestically, waiting for a trigger that loses the public's trust in future debt payments. Many countries, including the US, are beyond this threshold today with no signs of fiscal restraint. Traditionally, countries build up debt during periods of crisis or war, and then apply austerity measures to create debt surpluses, or use inflation's impact on nominal GDP to reduce the debt to GDP ratio. A high level of debt limits the ability for governments to pursue Keynesian spending during a time of need and increases the risk of inflation. In Japan, a long period of stagnation has formed a type of trap where low growth and high spending pushes down private investment in another kind of negative feedback loop. The U.S. budget was last in surplus at the end of the Clinton administration. Spending increased following 9/11, the great financial crisis, and COVID, and deficits continue today. The Federal Reserve has bought large amounts of this debt in various quantitative easing programs, increasing financial fragility even further. A restructuring of the dollar and other currencies seems likely, increasing demand for assets like gold and possibly cryptocurrencies. But it also means that a larger portion of a country's annual budget is taken up by interest payments, unavailable for other purposes and creating a negative feedback loop. A war or credit downgrade could also trigger a crisis. Some argue that modern monetary theory allows spending without consequence for a reserve currency, ignoring the underlying need for a balanced budget. This becomes an enabler and feedback loop as investor expectations become more negative about trustworthiness of the economy until a tipping point is reached, resulting in inflation. These doom loops are self-reinforcing, and it becomes hard to exit, with a combination of increasing interest rates and reduced economic growth leaving a spiral of increasing debt to GDP ratios until the system resets. Scenarios need to consider tipping points and feedback loops, especially in a complex adaptive system. An increasing pile of sand provides a good example. As grains are added, areas of weakness are created. They may collapse in a small landslide initially, or continue to build until a larger event occurs. Stability breeds instability. Minsky was right.
All right. Well, thank you, Max. That was very interesting. I've got a couple questions for you, as always. So tell us, how can we proactively identify potential tipping points within our organization rather than just reacting to them?
Well, first off, we need to look for them. Having a process that rewards those who scan for emerging risks can include feedback loops and tipping points, and starts the process of developing scenarios that shows which have positive or negative implications. Once you start looking, it's amazing how many things you see. We recently released a podcast discussing specific potential regime changes, and my picks didn't take long to develop. It's something I think about all the time. I think it's also useful to regularly get together with other risk experts to share ideas. Someone working at a chemical plant may have a concern that impacts climate or the financial markets. There's value gained from sharing. I teach an ERM class every year to college students and always learn something from them based on their personal experiences.
Well, thanks. So, next question, where are there opportunities hidden in these tipping points? Can we leverage our understanding of these dynamics to gain some sort of competitive advantage?
Well, I've long argued that developing foresight is a key to the survival for professionals going forward. with limited success. So I can tell you it's hard to gain industry traction. Believe me, you and I were not surprised to see a pandemic and its ramifications. Um, in any case, Dwight Eisenhower's comments on planning are useful. He said that specific plans weren't all that useful since your opponent will counter every move. But the process of planning is essential because it forces you to think about how you might react. This flexibility helps to form resilience. Today, you might move your headquarters away from the coast and limit financial leverage to generate an advantage by doing those things before you're forced to.
Well, thanks. So, Max, tell us, how should actuaries incorporate feedback loops into our stochastic models? Are we talking about regime switching models, agent-based models, or dynamic systems models?
Well, I tend to think of deterministic models when building scenarios, but have used regime switching models to manage assumption movement around the mean or to model fat tails with a different type of statistical distribution. Dave, do you have any thoughts here?
Well, I've done one agent-based model to model a complex adaptive system, and I found that to be tremendously insightful. Because of creating that model, I was able to understand that particular system much better and much faster than I would have otherwise. So I would encourage folks to consider agent-based models. Now, you may not know what an agent-based model is. An agent-based model is a model where you have created a micro world with relatively simple rules to that world and have the model populated by a bunch of agents. If you've ever played a computer strategy game where you're playing against the computer, the computer actors are just like the agents in an agent-based model. They've been programmed to doing some kind of strategy and will play it out. And if you've played one of those games, you know that the actual way that it plays out can be quite rich and diverse from time to time you do it. So you would create this model, you'd run it multiple times, and you'd watch to see what kind of things develop in the system. Sometimes the system may show you a long period of stable, nice times, and it may show you chaotic times. By looking at this, you gain a lot of insight about the system. Well, let's move on. If a debt to GDP tipping point, Max, triggers inflation or currency stress, how exposed are insurers with long duration fixed income portfolios? What would that mean for sovereign bond risk, which many insurers treat as a near risk-free asset?
Yeah, typically times are stable. I would talk about that if you're matched, you're pretty much in good shape. But if high inflation is triggered along with a slowing economy, then any modeling done that ties asset and liability behavior together will probably be wrong. Higher unemployment will increase lapses regardless of interest rate levels. Asset strategies should emphasize resilience and liquidity rather than reliance on stable trading markets. Liquidity is available when you least need it. And on the other question about sovereign bond risk, yes, if you get a credit downgrade, then that becomes, it starts to act more like a normal bond that has risk. It no longer is risk free. Dave, I have a couple questions for you. One of them, we're not giving investment advice, but what are some considerations on the asset side? Some people are talking about diversifying into real assets or inflation sensitive instruments to hedge systemic feedback loops. Do you have any thoughts on that?
Well, I think it's just like any other decision. You need to be able to understand those investments well enough to model them and to model them in these kind of dynamic environments that we're talking about and to see if they really do have the hedging effect that you're looking for. And I think the other thing that I know, at least from my own personal experience with those assets, is that they have definitely different accounting and tax treatment than regular commercial bonds. So you need to look at that very carefully. not just looking at the pre-tax effect, but also looking at the after-tax effect of those, and because they may not be matched in sort of the way you're used to having assets and liabilities matching on your accounting statement and on your tax return, so that the timing of recognition of the income, of the gains from them may be different, and the timing when you have to pay tax on the income may be different than what it would be for a bond. So you need to research that very carefully, and it may vary for different opportunities you might have of those different kinds of assets.
And Dave, one more question. A sand pile provides an effective demonstration of complex adaptive systems and how they work. You have been doing some groundbreaking work on today's, what I call wonder technology, artificial intelligence. Does AI accelerate this sand pile effect, increasing the likelihood of collapse and new levels of equilibrium?
The sand pile is an interesting analogy, but I think it misses the boat on a lot of the things we're looking at because it's not an adaptive system. It's a system where the tipping points are unpredictable, which is the thing that it is showing us, but it isn't showing us how the grains of sand don't adapt. Let me put it that way. But in a real system that we'd be looking at, people do adapt. And with AI, they'll adapt faster. But that's a problem because there's a classical system situation within systems analysis, looking at feedback loops, that when you have a feedback loop where the information coming back to you is delayed, what we've found is that those systems tend to oscillate because you're making a decision, you're taking your next step before you have full information on what happened from the previous decision, and you tend to overshoot. You tend to not necessarily get it right, to guess what the effect of the last decision you made was, and so those systems tend to cause a huge, or at least potentially huge, oscillation period. So with AI, AI will help you do analysis a lot faster, but it won't get you the information any faster necessarily. With AI, you're likely to get a more volatile system.
Yeah, your delayed feedback is interesting. It reminded me immediately of changes in the Federal Reserve rate, the interest rates, that it takes about a year for it really to kick in. And in that time, you've had several more opportunities to change that rate. It could be going in a totally different direction than you expected it to before it actually kicks in. So very interesting to think about. So thank you.
Thanks for listening. Before I let you go, I want to share my takeaways about this topic. In today's complex environment, relying solely on linear projections and recent data is a recipe for big surprises. Proactive risk management requires actively searching for nonlinear feedback loops and potential tipping points. The second point, you want to seek foresight, not just forecasts. The goal isn't to predict the exact future, but to build organizational resilience. The planning process itself, considering how you react at various regime changes, is what creates a true competitive advantage. And last, use simulations to understand complexity. For deep understanding of complex adaptive systems, consider tools like agent-based models. Creating a simple micro-world can reveal systemic behaviors and potential failures faster than traditional models alone. You can share your takeaways in the comments if you like. We hope that you've enjoyed this edition of Crossing Thin Ice, and if you did, please like, subscribe, and share with your friends. Thanks. Bye.